Hello folks, this will be a quick tutorial on inverse trig functions. Over here on the left hand side I have the graph of y equals sine x. Over here on the right hand side I have the graph of, or I will have the graph of y equals inverse sine of x, otherwise known as arc sine of x. Now you learn in Algebra 2 and that in order for a function to have an inverse function, we must have a one-to-one function. In other words, sine here needs to pass the the horizontal line test. However, it doesn't. So in order to make it work, we have to restrict the domain of sine so that the function will be one-to-one. And the way to do that for sine is you start from here and then you go up to here. So the pink is our restricted part of sine x. Well, this right here is negative pi over 2, and over here is pi over 2. So our domain is negative pi over 2 to pi over 2, and our range, as you can see, is just negative 1 to 1. Very simple. Okay? So in order to graph the inverse of this pink graph, we have to switch all the x and y coordinates, which means that the domain will become negative 1 to 1, and the range will become negative pi over 2 to pi over 2. And so I can put that on the graph. The domain is negative 1 to 1, and the range is going to be negative pi over 2 to pi over 2. Okay. Now we're not going to do the detailed steps in getting this graph. For now, just know that we have 1 comma pi over 2, negative 1 comma negative pi over 2, and the graph curves like this. Okay. So this right here, this blue graph, is the graph of inverse sine of x. Okay. If I were to superimpose the blue graph onto the pink graph, the two graphs would be symmetric along the line y equals x. Okay, so what are the implications here? Well, the range here is negative pi over 2 to pi over 2, which means that this is restricted to quadrants 1 and 4. When you first learn trig, you may have seen it shown this way. Okay, so what does that mean? It means that anytime we have an inverse sine function, anytime we're evaluating an inverse sine function, the output has to be in the range. And so here's the way I like to put it. The numbers that can go inside this box has to be between negative pi over 2 and pi over 2, because that's the range, the set of possible outputs for inverse sine. The only numbers that can go in that box are numbers between negative 1 and 1, because that's the domain of inverse sine, right? The range became the domain, and the domain became the range, as you can see. Okay? So what does that mean? Well, here are some quick examples. It means that if I were to do inverse sine of, say, something like negative 1/2, I have to think about an angle that is inside the range negative pi over 2 to pi over 2. In other words, I have to think of an angle in the first or fourth quadrant that has a sine value of negative 1/2. Well, you know that has to be fourth quadrant, and it has to be the angle closer to the x-axis, which is 11 pi over 6. However, we don't call it 11 pi over 6 because 11 pi over 6 is not inside this range. So you have to call that angle by a different name that is in the interval negative pi over 2 to pi over 2. And that would be negative pi over 6. Okay? Another example might be something like this. Inverse sine of, let's say we have negative 1. And so you think, where on the unit circle in quadrants 1 and 4, or possibly on the x or y axis, will sine be negative 1? Well, you know that it has to be down here. which is 3 pi over 2. But we don't call it 3 pi over 2, we call it negative pi over 2. Now let's get to more complicated examples. Okay, for example, we could have something like this. Inverse sine of 5 pi over 6. Okay, well, you think about the unit circle, and 5 pi over 6 is over here. Okay, now remember, whatever this equals to has to be in the range negative pi over 2 to pi over 2. Quadrants 1 or 4. However, as you can see, 5 pi over 6 is not in quadrant 1 or 4. So we have to come up with an angle in quadrant 1 or 4 that has the same sine value as the sine value at 5 pi over 6. The easiest way to do that is to just simply go across horizontally to this point, because these two pink points have the same y value. And you know that that's what sine is. Sine gives us the y value. So if this is 5 pi over 6, then this must be pi over 6, and the answer here is pi over 6. Okay? Let's do one more example with sine. Let's say I have sine inverse of sine. Let's say I have negative 2 pi over 3. Negative 2 pi over 3. Okay? Once again, whatever goes inside this box has to be between negative pi over 2 and pi over 2. Okay? So, let's see. Again, I'm going to draw the unit circle, and I'm going to locate negative 2 pi over 3. Well, negative 2 pi over 3 is right here. Okay? This is negative 2 pi over 3. Notice that it is not in quadrants 1 or 4. And so we have to find an angle in quadrant 1 or 4 that has the same sine value as the sine value at negative 2 pi over 3. So you go this way, and this angle is negative pi over 3. So the answer is negative pi over 3. Okay, so now let's talk about cosine and inverse cosine. Here I've already drawn all the stuff that we need to look at to see what the domain and range of inverse cosine is. As you can see over here, this is the cosine graph, which is once again not 1 to 1. And so in order to make this 1 to 1, we need to restrict the domain to 0 to pi. And so this pink portion is the only part of the cosine graph that we're going to keep. And so the domain becomes 0 to pi. The range, once again, is negative 1 to 1. Now, if we were to now sketch the inverse by switching x and y coordinates, or by reflecting over the line y equals x, we would get this blue graph on this side. Okay, and as you can see here, the domain of the original became the range of the inverse, and the range of the original became the domain of the inverse. So what does that mean? It means that when you evaluate inverse cosine, the only thing that can be inside this box that I am tracing over and over again, the only thing that can be inside this box are numbers between 0 and pi, because that's now the range. Well, this is quadrants 1 and 2. And the only numbers that can be in this box are numbers between negative 1 and 1. And so examples. Okay, if I do inverse cosine of root 3 over 2, okay, I think what angle in the first or second quadrant would have root 3 over 2 as a cosine value? Well, here are quadrants 1 and 2, and the angle in quadrant 1 and 2, oh, by the way, this is how people, oh, not that one, sorry. This is how people like to kind of show by just drawing the first upper half of the unit circle. All right, so where in this upper half of the unit circle is cosine root 3 over 2? Well, over here at pi over 6. Okay, let's look at another example. Inverse cosine of negative 1/2. And so we look at the quadrants 1 and 2, the unit circle in quadrants 1 and 2, and we ask, where in that range is cosine negative 1/2? Well, it has to be second quadrant, and it has to be over here, and so that would be 2 pi over 3. Now, let's look at more examples. Inverse cosine of cosine of 4 pi over 3. Okay? And so, we first think about the unit circle, and we say, where is 4 pi over 3? Well, 4 pi over 3 is right over here. That's 4 pi over 3. However, it's not in quadrants 1 and 2. Remember, the range for inverse cosine has to be quadrants 1 and 2, which means that our answer here has to be between 0 and pi. And so what we need to do is we need to find an angle in quadrant 1 or 2 that has the same cosine value as the cosine value at 4 pi over 3. And since cosine is the x-coordinate, all we have to do is go straight up over the x-axis to this angle right here, which is 2 pi over 3. So the answer here is 2 pi over 3. Okay, let's look at one more example with cosine. Okay, so inverse cosine of cosine of, let's do negative pi over 4 equals. Okay, so then let's draw the unit circle and let's locate negative pi over 4. Well, negative pi over 4 is right over here. Negative pi over 4. Okay, and so we need to now find an angle in quadrants 1 and 2 that have the same cosine value as the cosine value at negative pi over 4. So just like before, you just take this and go straight up to over here, which gives you positive pi over 4. So this is positive pi over 4. Okay, so now let's look at tangent. Well, here on the left, we have a graph of tangent, and as you can see, once again, the graph is not 1-to-1. In order to make it 1-to-1, we have to just take one period of it. So this pink part right here is 1-to-1, passes the horizontal line test. So we are restricting the domain to negative pi over 2 to pi over 2. Notice that this time we exclude negative pi over 2 and pi over 2 because we have asymptotes here. Okay? As you can see, the range is negative infinity to infinity. So what would the inverse graph look like? Well, if we reflect the pink graph over the line y equals x, we would get something like this. So this blue graph right there is the inverse tan graph. Notice once again that the domain of tan becomes the range of inverse tan, and the range of tan becomes the domain of inverse tan. So what does that mean? It means that the only possible outputs that can come out of inverse tan are numbers between negative pi over 2 to pi over 2, excluding negative pi over 2 and pi over 2. This is quadrants 1 and 4. And here's kind of a picture of how that might look like. Okay? All right, so let's look at some examples. Let's say I have inverse tan of negative root 3 over 3. Okay? So then we think about the unit circle, and we are only restricted to the first and fourth quadrants. And we think where inside the first or fourth quadrant is tangent negative root 3 over 3. And so you should come to the conclusion that it's this angle right here closer to the x-axis, 11 pi over 6. However, 11 pi over 6 is not in the interval negative pi over 2 to pi over 2, so we have to call this by a different name, negative pi over 6. So this is equal to negative pi over 6. Not 11 pi over 6, but negative pi over 6. Okay, let's look at another example. Let's say I have inverse tan of, let's say I have negative 1. Okay, inverse tan of negative 1. Well, where is tangent negative 1 in the first or fourth quadrant? Well, right here, and we now know that we need to call it negative pi over 4 because it needs to be a number that is between negative pi over 2 and pi over 2 because of what we see up here. Okay, so everything makes sense if you think about it as a whole. Okay. Okay, so now let's look at some examples. Some more examples. Let's say we have inverse tan of 2 pi over 3. Okay, so then we draw a circle, we draw a unit circle, and we locate 2 pi over 3. 2 pi over 3 is right over here. However, you know that when you evaluate inverse tan, we need to be in the first or fourth quadrant. And so, what we need to do is we need to find an angle in the first and fourth quadrant that has the same tangent value as the tangent value at 2 pi over 3. Well, tangent is negative at 2 pi over 3, so I need a quadrant that will give us a negative tangent value. And so the way you do this one is that you just take this and you go diagonally across to this angle right here, which is negative pi over 3. So the answer is negative pi over 3. Let's look at another example. Inverse tan of tangent of, let's now do negative 5 pi over 6. Okay? So we draw a unit circle and we locate negative 5 pi over 6, which is over here. This is negative 5 pi over 6. Well, it is not in the required range of the first or fourth quadrant. So, just like before, we're going to take this point and go diagonally through the origin to the other side. And this angle here is pi over 6. So the answer here is pi over 6. So now we will do some examples dealing with the sine, cosine, or tangent of certain inverse trig functions. With these problems, we need to draw a triangle to represent the unknown angle. So first, we start off with sine of inverse tan of 2/3. We want to think of inverse tan of 2/3 as an angle. And so we'll call it theta for now. So this problem comes down to sine theta. What we need to do now is we need to draw a picture for theta. Well, inverse tan is in the first or fourth quadrant, and so we'll draw it in the first quadrant because we have positive 2/3. Tangent is y over x, so we'll put 2 over there and 3 over there. Then we're going to use the Pythagorean theorem to find the missing side. And the missing side here is 13. So we use this picture, which represents theta, to find what sine theta is. And sine theta here is 2 over root 13, or 2 root 13 over 13. Okay? Now let's look at another example. Let's do now cosine of the inverse sine of negative 1/4. Okay? So we're going to think of this right here as theta. And so what we have is cosine theta. Let's now draw a picture to represent inverse sine of negative 1/4. Inverse sine has to be in quadrants 1 or 4. And since we have negative 1/4, it's going to be in the fourth quadrant. Sine is opposite over hypotenuse, so we'll put the negative 1 at the y length, and we'll put 4 where the hypotenuse is. We'll use the Pythagorean theorem to find that this missing side is root 15. So this picture here represents theta, and when we look at that, we know that cosine of theta is going to be root 15 over 4. Let's look at another example. Let's look at tangent of inverse cosine of negative 5/13. And so we're going to think of this as theta. And so this becomes tangent theta. And so we're going to draw a picture for theta. Now theta is inverse cosine, and so that means that we have to be in the first or second quadrant this time, because inverse cosine is quadrants 1 and 2. It's negative 5/13 that we're dealing with, and so we are in the second quadrant. Cosine is adjacent over hypotenuse, so we put the negative 5 and the 13 over there. Then we use the Pythagorean theorem or Pythagorean triples to know that that missing third side is 12. So then we use this picture to evaluate tangent of theta, and that is going to give us 12 over negative 5. Okay, we're almost done. Another example is something like the previous two examples, but a little bit more complex, a little bit more involved. Here we have tangent of inverse cosine of 3/5 plus inverse sine of negative 12/13. So what we have to do here is we have to think of this as an angle, which I will call alpha, and you have to think of this right here as a different angle, which I will call beta. So this problem becomes tangent of alpha plus beta. And if you were to expand that using the sum identity for tangent, we have tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. So now we need to draw pictures, just like the previous examples, to represent alpha and to represent beta. So let's do alpha first. Well, alpha is inverse cosine, so it has to be the first or second quadrant. We have positive 3/5, so it's going to be 3 right there and 5 right there. Using the Pythagorean theorem, the missing side is 4. Now we want to draw a picture for beta. Well, beta is inverse sine, which is first or fourth quadrant, and we have negative 12 over 13, so we're going to draw it in the fourth quadrant. Sine is opposite over hypotenuse, so the negative 12 goes here and the 13 goes there. Use the Pythagorean theorem or Pythagorean triples to find this missing side, which is 5. Okay? And so now that we have these two pictures, we can just plug them into this expression. Tan alpha, as you can see, is 4 over 3. So we have 4/3. Plus, tan beta, which is down here, is negative 12 over 5. So we have negative 12 over 5. All over 1 minus those same exact two numbers, 4/3 and negative 12 over 5. Okay? Now, there are different ways to simplify this. The easiest way is to just multiply everything by 15 over 15. And so we have 15 times 4/3, that will be 20, minus 15 times that will be 36 over 15 plus 48. So what we have here is negative 16 over 63. And that cannot be reduced, so that is our answer. All right, last example. I apologize for this video being pretty long. Here's the last example. Okay, here we have cosine of 2 times inverse tan of negative 0.4. Well, as before, this part right here represents an angle. So I'll call it theta, alpha, beta, doesn't matter. I'll call it theta over here. So what we have here is cosine of 2 theta, which I can write in one of 3 ways. This time I will choose this one. But know that there are 2 other possibilities. So now I need a picture to represent theta. Well, you know that inverse tan is in the first or fourth quadrant, and since it's negative 0.4, we will do the fourth quadrant. Well, negative 0.4 is the same as negative 4/10, which is the same as negative 2/5. So it's much better to use negative 2/5 than to use negative 0.4. So inverse tan, opposite over adjacent, means this is negative 2 and this is positive 5. The negative has to belong to the 2 or the 5. And as you can see in the picture, it should belong to negative 2. All right, then you use the Pythagorean theorem to find the third missing side. And so this time, you have 5 squared plus negative 2 squared gives you 29. So the third side is square root of 29. Okay, so now we're ready. We just use the picture. 1 minus 2 times sine, according to this picture, is opposite over hypotenuse. So the sine value is going to be negative 2 over square root of 29, and we're squaring the sine theta. And so here we have 1 minus 2 times positive 4 over 29. And so we have 1 minus 8 over 29, which is equal to 21 over 29. And so here is our answer. All right, this is it. Goodbye.